In this video, we're going to learn about pre-training and how it works. Before I dive in, please do subscribe to my YouTube channel and follow me on TikTok. So, pre-training stage is the initial stage of training a large language model, where the model learns general patterns, features, and knowledge from a large data set. And now that large data set could be a unstructured data set. This stage does not focus on a specific task in mind, but instead builds the foundation understanding of the data, enabling the model to be fine-tuned for specific tasks later on. So at this stage, you're just learning from the data set. So now we're going to cover the key features of pre-training and how it works. So pre-training is done on large data sets. Most of the data sets is unlabeled. So the models are trained on massive data set containing diverse data from books, website, news, and any open source out there to learn the structure and the meaning from that data. And as we said, the data is unlabeled, so unstructured. The model learns by solving tasks like predicting missing words, so the maxed language modeling, or the next word in a sequence. And you could look into it in more details if you are interested. Also, you could look into transfer learning and how the model could be fine-tuned for more of like a smaller task-specific, domain-specific data set. That's another thing to look into as well. So how does pre-training work? We're going to keep this short but simple so it can be understood. So we have the input text. So the model is exposed to raw text from large data set, as we said, Wikipedia, any open sources resources that we could find. And we have the tokenization. The text is broken into smaller units, so which is our tokens, which the model processes. For example, sentences like the cat sat on the mat. The tokens will be broken down into each word. So like the cat sat on the mat. So this is tokenization, how the model will be able to learn. We have the self-supervised tags. The model is trained using tags where it generates its own label from the data. So common tags include maxed language modeling, as we spoke earlier about it, and the max sum word and predict them. So input will be and then there will be a gap and the sat on the mat. So the model will have to predict the word in that mask, so which will be the cat. So that's like training the model. And then we have the causal language modeling, which is predicting the next word in a sequence. So you might give the model input like the cat sat on the, and there's a gap. So the model will have to predict the word. So it will be mat. So the model will predict the word mat. So this is how it's trained. And the next sentence prediction, which is the NSP. It predicts whether one sentence logically follows another. So used in BERT. So BERT is a text classification purpose model. That's large language model as well. So you can look into BERT if you're interested. And optimization wise, the model adjusts its parameters using a loss function, which is called cross-Entropy loss, to minimize prediction errors during training. So we'll shortly cover what is the cross-Entropy loss. The cross-Entropy loss measures how well a model's predict probabilities match the actual labels. So it shows how wrong the model is. So in simple terms, if the model predicts high probability for the correct answer, the loss is low. If the model predicts the lower probability for the correct answer, the loss is high. So if you want to look into cross-entropy loss, you could look into the loss function a bit more and study a bit more about how it works. That's all for today. Thank you so much. If you enjoyed this video, please do like and comment and subscribe and follow so I can make more videos. Thank you.